Hi everyone, I'm Logan, a founding engineer at InstaLILY. Today I'll be talking a little bit about Model Context Protocol, or MCP. So currently, whenever you implement anything with AI or LLM specifically, whenever you want to have an LLM act as an agent and execute some type of tool, help you send out an email, help you do some research, understand some type of workflow and action within your system, that tool execution, it's always almost ad hoc coding. It's single-use code that doesn't swap between different contexts, cannot be leveraged in other work streams or verticals, and essentially you'll be doing a lot of repeated work. Let's say we have an agent here. You want to handle some type of query. And so you develop a bunch of tools associated with that agent. It gets mounted and it's used by that agent, right? Send email, get my sales KPIs, how is this process going? How's my delivery going? What's the status around that? Those are tools that you natively embed within your agent. However, when you want to get to more complex use cases, that really gets difficult to manage. And I'll give you an example. So let's say we make this agent like a sales agent. It helps out your sales team with fetching data for some type of particular KPI, right? And you define a set of tools that's embedded within this agent. Let's say we have a different side, an ops agent. The ops team is not going to use your system because they have different, set of requirements. However, they might need to see how your sales KPIs are happening, and they would have to go to your department and ask for a copy of that code, implement that. Then you get a branched off version, which gets really messy to handle, right? Because this is natively embedded within your sales agent. If you want to duplicate that, it makes management a nightmare, for example, when you want to scale up to dozens of tools across multiple different verticals, 5 or 6 different implementations, right? So this is where Model Context Protocol steps in. So instead of having tools being created, forked off into other instances, things start splitting and branching off, but it serves the same purpose. This is where MCP really shines, because we can create a single layer in which we have different tools. 1, 2, 3, 4. Here we can have multiple tools that exist. Let's just introduce some example data. They have Snowflake, Salesforce. There's so many different permutations that's going to happen, right? If we didn't have this MCP layer. But here, let's say we have a Snowflake tool that fetches, data aggregation. This one fetches the latest data KPIs. This tool number 3, this writes in, a sales order as an entry within your Salesforce system, right? We can just simply connect this MCP server to this sales agent. We can connect this to the ops agent, and those tools all get mounted in multiple different places, but you only need to maintain one instance of it. So that makes scaling up significantly easier. And you can even have multiple MCP servers that serve different purposes or use cases that also embed into these different agentic systems. So as you can imagine, instead of having a tool embedded here, you copy the code, have them embedded, and then that goes on and on and on. This makes management so much more easy and makes use cases for agentic systems much more streamlined and scalable. This is just the basics of MCP, but essentially at InstaLILY, this is how we think about it. And thank you for listening.